Hi, I'm Ramon from Excel MBI. I would like to appreciate you watching this class. This is a module that I have prepared for our training classes, and which is about a starter schema and about the importance in BI tools like Power BI. I hope you enjoy it. If you have any question, feel free to flick me an email. Have a good day. Starter schema, which is super important concept when we're doing data warehousing, and also when we do the structure of the process. For example, when we're talking about organizing the data, a starter schema is a concept that will start to resonate with you. All right. Then the importance of starter schemas on Power BI, and then we'll review what if we are not using a starter schema. And lastly, have an example review. Okay. A starter schema is a big concept, and some people were full-time doing data modeling, and that is why it become important nowadays, because tools like Power BI really rely on a star schema to be able to create their reports, and that is why the importance of using this kind of structure. And I will explain you what is this. If we go into the dictionary, or we go into Wikipedia, or even as to our favorite chat AI bot, a star schema definition is a type of data modeling structure used in data warehouses and analytic systems. Data modeling is the process. Data modeling is the process to know from where the data comes from and organizing in a certain way that it will be really good for storing that information, and also it will be easier for everyone. If you are interested to go deep down in data modeling, I would strongly recommend you the Kimball model, which is the guru when we have speak about data modeling. Those guys are so good. They have heaps of books, and it's a lot of documentation. And the special concepts that we need to understand on star schema will be reviewed in 1 second. The why star schemas are important. It simplifies queries and improve performance in BI tools, especially in Power BI, which this is what we'll be reviewing today. It makes it easy for business users to explore the data. When you are doing aggregation or start to go deep down on certain information that someone requires you, if you have the data properly structured, you just append like the stock sales or the inventory or the quotes, for example. You just merge them, which I will be sure that in a second as well. And reduce data redundancy, because we don't want to have multiple names for the same customers. That is why when you do a proper data warehousing process, it will standardize customer names. It will standardize address location. For example, have you run once into a spreadsheet and then you see the same the same customer ID, however, the name differ and also the address for the customer is different, and then you start to find like what could be happening. Or for example, there's a typo error for someone who entered the customer wrong twice. That is why the importance of a standardization of the data. How this process gets started, and everything starts from flat tables. That is, you can call it Excel sheets, a third-party app table, website, a CRM. You can could be even a separate SQL table, or it could be even a separate cloud table, SharePoint, any kind of source for your data that you need to transform later on. It will be your base. All right. Then when you get the instruction, you mean, for example, I brought the data from the CRM, I brought the data from the ERP, and then I brought the data from the marketing campaigns. All of them, they get into a transformation stage, which is when we transform the data and we standardize. For example, we extract the customer's IDs, we put just them distinct, and we create a table, and that is how we start the processing of the star schema creation. And then we have all this data organized. We move it into a warehouse. A warehouse is a concept that you will start to see more often when you work in data analytics, because putting unstructured data into a place, we call it lake. However, when you start to organize the data, we call it warehouse, which means it's just for you to go and grab the data. Whatever that it happened every day, like the sales get loaded yesterday and that's sort of process, you will be able to just go to that place, extract the information that you need, and you don't worry if that sales intake it happened or not. Normally, those processes are automated, which is the ideal scenario, of course, and this is what we call ETL, which is extraction, transformation, and loaded from the data into a warehouse. As you can see, now we start to see a star schema inside of a data warehouse, which will contain, for example, dimension tables, which are the elements that goes around the fact table, and this is the fact table. The fact table will store the transactional information. For example, here we will see the date, we will see the customer ID. However, the elements that we won't see on the fact table, it will be the customer name, the customer address, the contact person, and so on and so forth. All those columns will be contained in the dim customer. As I just mentioned, the tables that goes around the fact table are called dimension tables or DIMs. DIMs are normally called on data modeling. However, that name comes from dimensional tables. You can create as many dimensions as you want, but the good part here is like you will have one fact table for sales, one fact table for inventory, one fact table. I don't know what the balloons come up. I think it's because I did something with my fingers. Sorry about that. One of the elements that you will start to see like is one fact table for sales and multiple dimensions, but then if you have an inventory fact, you can reuse the dimension tables. You don't need to start to create multiple dimension tables. That is why when these models start to grow, you can have 10 fact tables and just 5 dimension tables. And those one allows you to do interaction among those tables, which is something that I will show you in a second. Of course, this warehouse can be saved in your own server, or it can be saved on cloud servers. Nowadays, there are tools like Google Cloud, or there are tools like Azure, which is the Microsoft solution, or we have AWS, which is the Amazon solution. If you put this one here, you are using the cloud, or there are so many companies that they trust more in their own servers, and they put just information here inside. Whatever that you put in, you're still doing that warehouses, and you can call it like that. How those tables are saved? It can be saved in Parquet, it can save on notebooks, it can save on JSON, it can be saved on SQL Server. There are different kind of ways how you can store this information, but it still will be called a warehouse. What are the key elements that I just mentioned? Is the fact tables, the dimension tables, and the table relationships. Those are the 3 main elements that you need to be aware of when you work with the star schemas. Okay? And now if we go into the practice, this is how a table looks like. You know that when you extract the data from sales, this is how it looks like. But now we need to start to extract certain information to put into the fact table and certain information to put into the dimension table. And the way how we do it is to select the transactional data and put it into the fact table. And what it will be the transactional data? It will be this. The transactional data will be date. For example, when it happened the transaction. For example, this is a transaction for me. Each row is a transaction. Don't worry about the wrong country and the wrong city. It's just because it's a sample test that I created in Python. Okay. All right. This is a unique transaction, and the thing has been solved as a monitor, and it has different categories, which are part of the features for the dimension table. As you can see, all those 3 columns, this one, this one, this one, this one, this one, and this one, it will go into the fact table. Then it will be able to create something called fact underscore cells. That will be my fact table. And our dimension tables, I think we can group it into two. What it could be the location, and the other one could be the product feature. Because in a product we have multiple feature, and instead of to create so many records for the category, so many records for the subcategory, we can start to create a dimension. And the way how we can create a dimension is to just bring those three columns and put in something called dim product, and bring those three other columns and create something called dim city. With this, we'll be able to light it out the table, which means we could make it lighter, because happy days when you have 1,000 records, but when you have millions of records, every column, it costs you storage in the data warehouse, but at the same time, it costs you speed on your analysis, which means that if we have a table like this, it will be super heavy to load. However, if we had just a table like this, it will be super easy to be picked up by Power BI or the tool that you're using for analysis. Oof. I will take a stop, a pause, sorry. All right. Do you have any questions so far? If you have a question, please feel free to move out from mute. Thank you very much. Okay, what are the importance of the star schemas, or what is the importance of proper data modeling into Power BI? Is because Power BI works optimized with slicings. Slicers are the concepts when we graph an information from here and we filter out from here. For example, we only have the one number that identify the product, and it goes here. You see this connection is from one to many. That star means many. And if we like to filter by the category, we don't need to have the category here to be able to filter it. As long as it's in the dimension table and this relationship is created correctly, we could do any kind of filter for whatever that is here in this dimension or whatever is here in the dimension. For example, with a proper relationship, I could do easily a count of the cells for a specific city, okay? Or if we like to do a specific count of the cell for a category, a special category, it can easily be done. And for Power BI, this is transparent, and it works pretty much as a VLOOKUP or XLOOKUP in Excel. The difference between when you do a XLOOKUP or a VLOOKUP in Excel, that take a whole bunch of resources on your spreadsheet and in your computer, of course. However, in Power BI, this works naturally and is really optimized to be work like this. This is why it's so important star schemas for BI tools, not just Power BI, but BI tools, and it's a great way to store data as well. Importance in Power BI, as I just mentioned, performance. We always look for performance in Power BI. We want to get the attention from our stakeholder when they interact into our dashboards. We don't want them to wait 2 minutes to make the visual be loaded. That is the importance of have fast queries. And the other thing, storing the data in a star schema makes clarity and reusability. It's a hard word for me, thank you. This is why you can use many DIMs as many times, you can use one DIM many times. That is the importance of reusability of the data when we create a proper dimension tables. You don't want to create a table called DIM underscore product 1, DIM underscore product 2, then it will start have duplications, which is not so really necessary. Also, the scalability is great because you dimension just grows row by row, like 10 rows every time that you do a full load. However, your fact can grow hugely, but your dimension will be still reusable. Also, it creates clean relationships. When you do a proper data modeling, you do a clean relationships, which is the ideal scenario, which having the right connection from one to many. There's something we'll also review in the example shortly. And also we create a optimized DAX formula. Instead of to have 150 super chunky DAX formulas in Power BI, DAX formulas is the language that we use in Power BI to create calculations. We have really simple DAX formulas. I have seen when you load a flat table, for example, that table that you just seen here, if you load it completely into Power BI, to be able to start to create a calculation, you need to bring this one from this one from this one and try to make connections. And that is make really inefficient the DAX formula, and you end up with a huge DAX formula. However, when you have a proper modeling, you ended up with a super short DAX formula. I will show you a formula in a second. And what happens if you don't use it? I'm sorry to say this, but I think that you will be in trouble if you don't use it, because happy days when you do it once. However, the more and more that you do, it start to create a hassle, and the heavier that those flat tables start to be, and it will create a more performance issue. I've been on the stage that I started before I start to learn star modeling. I used to load flat tables. When it was small, happy days, no one complained, performance was good, everything all right. However, everyone started to like the Power BI and start to put more data into those tables. And they asked me, Ramon, can you put this another table? And Ramon, can you put this another table? Yeah, no problem. And Power BI allows you to put adding more flat and flat tables. And the thing that happened, everything started to crash and it was super slow. Power BI doesn't crash, but it takes a whole bunch of resources from your local computer or from the web application. And then I ended up with Power BIs that take around 2 minutes to just be refreshed when you filter for a different customer. And that is something that we don't want to see nowadays. Nowadays, we are in times of everything needs to be fast and immediately. No one wants to wait for get a report 5 to 10 minutes, or for you looking for a customer statement, for example. But of course, using flat tables, it will create problems, as I just explained before. It will create repetitive information that is not necessary. It will slow down the process. It will be hard to maintain, because let's check if you have an Excel sheet and you ingest that into your Power BI. However, someone go to the spreadsheet, you create a new record, and then you try to update the Power BI, and that Excel sheet got corrupted, and that will be a really hassle. And that it happens when you have to share folders, when you have share, for example, a spreadsheet for sales opportunities, and everyone start to add their own ones, and then start to create corruption, and then your Power BI, it will crash, unfortunately. However, with a proper data warehousing process, happy days, because you will not have those kind of problems. Hi, it's me again. I hope you enjoyed the theoretical part. This is really important for you to understand the technical part on the architecture that we'll be working today. And now we are ready to jump into the practical part. We'll be providing you certain tools, and also we'll review how we can apply the star schema that we just made into Power BI. Also, you will get access to our free tool, which will allow you to compare flat tables into a star schema. Hope you enjoy this practical part. I made a tool for you that you can just download it. It's a software that I made for you, just for you, because you are special. This software allows you to create star schemas from a flat file, which is, some people could say that it's not effective for every single solution, but it's really good for learning. Okay. And the way how it works, this software, you don't need to install it. It's just an executable software, and you need to be able to see all those buttons here. And the first step, and it will be in the link that I will be sharing with you by email, is the step 1, which asks you to import your flat file. Together with this example, this software, it comes with a sample data. And this example, it will ask you to open the file. You can either select CSV or Excel. Those are the acceptable format for this tool. You just open it. And here you will be able to see what is the previous of the information that is contained on that Excel sheet. And as I mentioned, the fact table, it will contain the transactional data. And this is what I do here. I will select the transactional data and customer ID. I will select the quantity, unit price, discount, and total sales. I will leave those elements to put in the dimension, but I just select the ones that I would like to use in the fact. That is the step 2, sorry. I will do the step 2 first. The step 2, it says create a dimension tables. First dimension table that I will create is the dim product. I will select those 3 categories that are related each other, and I will put them in a new dimensional table. How I do it, I just click here, I select those 3, I click here, and I will call it dim product. All right. And it will go here. This is my first dimension. Now I would like to create the second dimension, which will be the city, dim city. I will select those 3, which are contain the information from the city, and I will just create again then step 2, and I will create the dim city. And now I have 2 dimensions. Now it's the turn to create my fact table. Every time when I do a selection, I just click this button, which and clear the checkbox. Now I can do the fact table, which will contain all the leftovers elements, which are the order date, the customer ID, the quantity, the unit price, the discount, and the total sales. And now create the find fact table. And as you can see, this one go loaded up directly here. Now I have 2 options. One, I can export those dimension and model in Excel, which could be useful if you're not familiar with something called Parquet, which is the best one of the best format to import data into Power BI. However, we can just stick to Excel. All right. I just click here, export into Excel, and I need to select a folder where I would like to save it. You can create a new folder, but I will recommend you to create a specific folder just for those tables. I will save it here because I have pre-create this folder before, and I will click select folder, and the export has been completed. Or I can do it in Parquet file, and the way how I do in Parquet file, I will go here, which is the other folder, and I will just click select folder, and it's done. And if I go back to those 2 folders, this is how I look like now. If I go to Excel, yeah, here you can see the 3 files that will be represent my star schema. All right. And if I open this up, you will see something new in the fact table, which is called, I will just select this, and then I will expand this up. You see there's a new element called dim product SK and dim city SK. This is something called surrogate keys, and those surrogate keys I created to make the relationship between this one and the dim table. For example, if I go to the dim product, you see this dim product, it has multiple numbers. And this one means that if the one is here, means that this transaction, it will have the product monitor, category, accessories, and stationery. Those are the 3 elements that will be connected to here. And the way how we do the connection is with the surrogate key. And those are the lines that you see in Power BI. When you do the connection from here to here, is it called relationship. Okay. And then you have the dim city, which is exactly the same scenario. But if you see those numbers are not consecutive, and it doesn't need to be, and the reason why is because this one is the number 8. This is a transaction for a tablet. that it has the category electronics, and it is part from the furniture subcategory. And if you can see, you have all those numbers all the way long, and we don't have any duplicates. For example, we have 62 elements only, but in the transactional table, the fact table, we have in total 1280 records. That is why we have optimized a lot the fact table. And of course, for data warehousing, integer or a number data value is much lighter than saving a bar chart or a string value. This is why this table start to get lighter and lighter. Now I will go to the Power BI to see how these tables look like. If I go, I have also this example that I also will provide this to you, and that way you can play with this technology. It should come up in a second. Do you have any questions so far? No? All right. Let's keep going on this. All right. The way where you load the data is here, and you do it on the transform data. And then here you can see the connection with my three Excel files. And as you can see, those are the 3 dimensions on the fact table. When you do this naming properly, when you create this product SK with the fact table and then product SK here, automatically when you do the connection in Power BI, it will create those relationships. But this is what we would like to see always, from 1 to many on this direction, from the dimension product into the fact table. Every time that you see fact tables or star schema, this is the ideal scenario. There are scenarios that you have to do a many-to-many. However, there are other solutions that you can use to tackle that challenges. In the place where in Power BI you see this is in the model view. All right, this is the way how you see this calculation. And just to show you some examples, I have put the information here, but if you can see, for example, here, I start to create the data to replicate back the table that I have from the source, and you can easily do. And the way how it works, like, for example, you can put here the product, the country, and the total sales. Sorry, the sales is not showing in sales. Unit price, I will put this in number. Yeah, that looks better. All right. The thing that I want to show you here is like, no matter if you put in a different tables, as long as it has a proper relationship, it will create this, you will be able to put this information here. And now, as I just mentioned, when you create a measure, it's really easy to do it, and you can make the relation because the relationships are already created by you in the model view. And now you can just create, tell me the total sales from Australia. And I will do a sum of total sales. And now I just can add the filter to Australia. We use calculate to create the expression, which is, this is the operation. And here we can do filters, comma. And I want to just want the country. If you see, I just type the country. And as soon as it comes with the dim, and if you see, we are relating two tables, and this come naturally in Power BI because we did a proper star schema. And then I will put Australia. And now that's all. You don't need to do anything more to create a calculation when you do a proper model. And if I click this, you will be able to see the total sales. Well done. You just completed the first practical experience. I hope you enjoyed. I think and I strongly believe that attaching the theoretical part within the practical part, it will make you those concepts stick into your brain. Well done. So now ready to jump to the next module. Well done.